Thank you, everybody, for coming today. Lovely Sunday and spending your time here. That's excellent. Wonderful. I'd like to thank Srijan for organizing this talk. As usual, wonderful to be back in Delhi. So today, like talked on Indic roots of modern knowledge systems. And even before I start the talk, I'd like to clarify, anticipating certain pushback on this. There are people who say, am I being excessively jingoistic by trying to say that Indic knowledge came from, most of the world knowledge systems came from India? Is that what I'm trying to say? Things of this nature. And I assure you not. I'm a person who's primarily seeing the existing narratives, deconstructing them, and trying to see, is there an alternative narrative that fits the evidence? And I'm presenting to you whatever that is. So if you've seen my earlier talks, you'd perhaps have appreciated the antiquity of the Indian civilization. I'm not going to be repeating that over here. So it's a given that the civilization is pretty ancient. People have been around in India for a pretty long time and have had time to encounter problems or issues or ideas that confront the human civilization and propose solutions to them. So that's the main reason you find that a lot of knowledge systems came out in India. So I'm going to be talking about technological heritage, mathematical, astronomical, medical, and music. So in ancient Indian philosophical systems, we had talked about this earlier. I won't talk much about this, but this is a prelude. This is a prelude to tell you that here's a civilization that placed great emphasis on the generation of knowledge. So the knowledge generation was pramana, and different schools of thought came up with different ideas on what are the admissible paths for knowledge systems on Nyaya, Yoga, Vaisheshika, Samkhya, Purvamimamsa, Vedanta, and Jain and Buddhist works. And most of the knowledge systems of the ancient past only differed in what was admissible as a source of knowledge. For example, the Charvakas said perception alone, only if we can see it, then it's something that is valid. So they rejected the Vedas as a source of knowledge. They said only direct experience is what gives rise to knowledge. That is their way of looking at things. Buddhism looked at perception and inference, which is echoing the journey of Gautama Buddha. He went through some trials and tribulations on his path to nirvana, and so it reflects that kind of a system over here. So you see that what I presented in the earlier page, Samkhya, Nyaya, Vaisheshika, Mimamsa, Advaita, they only differed from the admissible schools. Samkhya was perception and inference, Nyaya took this, and comparison and analogy, and so on. So when you go, by the time you reach Advaita, it's pretty open in trying to take different pathways to knowledge. That's the way to put it. So the example that I give is in today's world, if you're doing your PhD thesis, you typically might want to refer to some professor, maybe from Berkeley or Harvard or some such place, and you might say that he has proved a certain theorem in his works, and on the basis of his theorem, reference 1, I'm going to prove my theorem, and my thesis is based on that work. So you're relying on the Shabda Pramana of some professor who came before you. You have accorded or privileged his ideas as really good, and you take that as an authentic source of knowledge. Based on that, you write your thesis. That's the way we do it today. But in the ancient Indian world, depending on the sampradaya in which you belong to, various means of admitting knowledge were present. That is the bottom line. Given a comparative outlook on life, primarily to see the conduciveness to knowledge. Not all cultures had a philosophy that was conducive to knowledge. So at a very high level, I have the dharmic and the Western Abrahamic categories over here. Goal of life was to dispel avidya, journey across lifetimes, aware of karma, dharmic living, and the goal is to attain moksha, whereas here it was to follow a divine dictated law for judged admission to heaven or eternal damnation, and you have one life to live. That is the philosophy of life over there. These big questions of today, how do the dharmic people and the Abrahamic people encounter that? Theory of evolution, we are enjoined in dharmic systems to use the darshanas to appreciate whatever is vidya and avidya and make sense of theory of evolution. Whereas over here, it's against the history centricism of creation, that creation was a God-mandated event at one particular point in time. God created the universe and so on. Climate change, we understand our role in contributing to carbon, and if we reduce the carbon footprint, I say that's equal to reducing our karmic footprint. We understand our karma and live dharmically. So if you can afford to drive let's say a hybrid or an electric car, you do that rather than driving a gas guzzler. You have a conscious choice on what you choose to make out of life. So, in the Abrahamic way of looking at things, God has put man in charge of creation. Thus, this has led to unabated destruction today, and there's a tendency to deny climate change because climate change does not exist. God has put you in charge of everything. Sustainable living and compassion for all life. We recognize the Atman in all life, live dharmically, mindful of the karma that we are generating. Over here, man has sovereignty over all life. Animals have no soul. Therefore, there isn't compassion to animals and we can exploit at will. The issue of an ancient earth, we can use darshanas to appreciate Vidya and Avidya again due to history centrism of creation. The earth is not ancient in this way of thinking. And tomorrow, if there is life to be found outside earth, then we would again have no problem in the dharmic framework, appreciate using Vidya, Avidya. Whereas in the Western frameworks, due to history centrism of creation, there would be some problems over here. So the bottom line is I'm trying to show what is the outlook on life and is it conducive to knowledge or not. So that said, I'm going to now breeze through the conclusion of my talk because I don't think I'll have time to get to the conclusion. So I will straight away talk about the conclusion. So the roots of medicine, we see medicine roots in Atharva Veda, which led to Ayurveda. Charaka, Sushruta Samhita were compendiums of Indic medical knowledge. The Mitannis, Hittites, Egyptians, Chinese were influenced by Indic systems. Medieval Europe depended strongly on drugs from India. Arab medicine based on Ayurveda since Bin Qasim's invasion of Sindh. Ayurveda formed a corpus of European knowledge right through the colonial era. And Ayurveda was taught in British medical schools in India till 1880. Until such time, their own systems came up, the digestion of Ayurveda was complete, and it formed the core pharmaceutical methods in the system. I'm also going to be touching on mathematics. And it's very pretentious to try and say I'm going to cover all of Indic knowledge systems in a 1-hour talk. I mean, that is very insulting. So there's no way we can do it. So there's going to be snippets here and there. So math had origins in the Vedas with number systems, large numbers, operations. We know about the Sulba Sutras of Baudhayana, showing greatly refined knowledge of geometry, square roots, and so on. By Aryabhata's time, we have greatly refined trigonometry, spherical geometry, and algebra. Surya Siddhanta shows intricate math and astronomical knowledge and refers to extinct Siddhantas. We'll talk about that. By the time we come to Brahmagupta, Bhaskara 1 and 2, greatly added to a corpus of works on algebra, positional math, zero, and so on. Kerala School of Math greatly refined astronomical models and developed the essence of calculus. And right down to our times, Ramanujam continued the tradition of Indian mathematicians with deep results in infinite series. I'd like to also talk on the roots of music. So I'd like to talk to you about how the earliest musical systems originated from the Samaveda. The 3-tonal liturgical music in Samaveda gave way to the 5-tone, to the 7-tone, to the 12 semitone scales. We'll talk about that. Musical intervals are based on chord ratio. This is not a C-H-O-R-D, this is a C-O-R-D, chord, Sulba Sutras, chords, chord ratios. Pythagoras used the same ratios and is originator of the Western musical traditions. We will talk about Pythagoras and how he used certain ratios for music, considering it to be divine, and erected a statue for the goddess of music. Muses will talk about that. Talk about roots of astronomy, where initially astronomical knowledge embedded in stories. Then we went to heliocentric model, which is encoded in Satapatha Brahmana and Aitreya Brahmana, used by the Greek Aristarchus. Gave way to Siddhantic astronomy, and many of these works are lost today. Mathematical models to estimate the course of sun, moon, and planets. Development of trigonometry, spherical geometry. This is also used by the Greeks. Models to estimate eclipses, duration, length of shadows, Aryabhata. Estimation of circumference of the earth and curvature, Brahmagupta. And the rate of precision, Bhaskara 2. Model for partial heliocentrism, Nilakanta Somayaji. Copernicus was influenced by Aristarchus, who was influenced by these works, and he exchanged the position of sun and earth in the known models, and he came about the heliocentrism. Many centers of learning were destroyed in India by Muslim invasions, and the last great classical astronomer was Pathani Samanta Chandrasekhar, and we'll talk about that. Then the roots of our modern systems. So today we cannot live in a world where you are not digitally connected. If you're not digitally connected, it's like you don't exist. So the basis of everything is in digital systems, whether it is computers, cell phones, internet, and very, very pervasive digital systems. The Nasadiya Sukta has got examples like this A and not A in its kind of logic. There's very, very clearly a Boolean algebra kind of a formulation. And this is not the only one. When you go to Nyaya and other schools of logic, you'll find that there's a lot of logical statements encoded in them. So Colebrooke wrote a work on Indian logic in 1824, and this work greatly influenced these two gentlemen. This is De Morgan, and this is George Boole. So anybody here who's an electrical engineer will recognize these names because these were the people who wrote the algebraic theory of Boolean algebra. Once that was done, then it was very easy to progress from there on to technological innovation. So it influenced George Boole and De Morgan. And Boole's wife, Mary Everest Boole, wrote a letter to Bose outlining the influence of Indian logic on Boole and De Morgan. So the use of Boolean algebra is what has enabled the design development of complex digital systems. So the key over here is not to claim that Indians invented anything. There is no Indian who invented the transistor. The transistor was invented by Shockley. So we know that. We know that. So, but the point is, ideas don't come in isolation. We live in a connected world. Ideas go from one place to the other. Ideas germinate our thinking. And from that thinking, we move on to something else. You all know that when you're discussing with your friends, suddenly you get a brainwave. But if you're sitting in your room working alone, you probably would not have chance from that kind of thinking. So that is what I'm laying out a path for, saying that Indian knowledge systems seeded world knowledge systems. And so we are the recipients of a knowledge system starting from a trajectory from the ancient Indians. That's what I'm trying to emphasize over here. So I'd like to very quickly set the stage by showing you lovely pictures. These are pictures that will demonstrate the technological prowess of our ancestors. So here's a lovely temple. The lights were off, you could make out. This is the Rani Ki Vav, as you would have noticed it, and 1050. Observe how beautiful the layout of this whole thing is. Brihadishwara, many of you would have heard about Brihadishwara in Thanjavur, and built in 1010. Lovely temple, maybe the biggest temple I've seen at least. I don't know, there's a bigger one in India. It's called Periyakovil for a reason. It's a very big temple. In Maharashtra, Ellora, I don't believe this date. I just read a work yesterday where a person talked about some Greeks mentioning the Ellora caves around 260 or so current era. So there's no way I trust these dates. So we know about this very lovely rock-cut temples. It's an engineering marvel if you look at it. And in Halebid, I apologize for the quality of the picture, but then these appear to be pillars that are turned on a lathe, very, very smoothly done, very round and so on. This is in Rameshwaram. It was built in the 11th century and once again in 1750. And you can see how there's vanishing lines, parallel lines, as you can see, lovely perspective over here. And this is one more, Konark, Odisha. We know about this also. Now, when you see these things, the first thing that must come to your mind is, how did our ancestors build these things? Is it that the king gave some money to the people who do these things and they took some chisels and started working on it? How did they do that? Because today we know that if you're going to build a huge building like this, you go to a CAD or somebody who does computer-aided design, does the layout, does the engineering calculations, does how much of load can each pillar take. Based on that, we build buildings today. How did your ancestors do this? That is the question. To my surprise, I found that they were using engineering scale diagrams way back in the 10th century, way back in the 9th century. This is from a talk with Professor Arun Iyengar. You can Google for this and find it on YouTube. And he shows this particular work. There's a book over here out of which he shows these pictures. These are all palm leaf diagrams. So you can see that each of these is a palm leaf diagram. And these palm leaf diagrams placed one below the other gives you a perspective of the entire temple as such. And if you look at this in detail, there is actually detailed calculations that show you how each section should be built. Even the wheel at Konark, detailed instructions on how that wheel should be built. And not just that, if you go, you can see deeper and deeper into these works, it even talks about how much of work is involved, how much of money to pay this. So in other words, engineering work order. It's even telling you that I need 5 people to work on this particular aspect. They have to be paid at so much. This is what they had to give, and so on and so forth. Lots of interesting information. Take a look at this. Intricate information on how this temple should be built. So this, when I saw it, blew me away. Because I said, till then, I was under the impression that, all right, engineering came to us once the Europeans came here, and only after that we were using mathematics and building these huge buildings. This is a revelation. that there was actually, in this case, we have the palm leaves. We don't have the palm leaves in many other places, so we don't even know how they were built. If you go to Brihadishwara, there's epigraphy that says who built it, but doesn't say how it was built. In Konark, we are lucky that there actually are palm leaves that detail the entire construction process. So amazing, amazing piece of work. Very brief on metallurgy. Metallurgy finds mentioned Rig Veda, Atharva Veda from earlier than 3000 BCE, copper, bronze, iron, wood, steel, gold, silver, and zinc. We have archaeological artifacts from 2300. Here's, for example, copper plate, which could have been a prototype for a printing block in addition, knives, and the famous pillar over here, and so on. So what I've done over here is I started out the series with showing you lovely pictures of Indian engineering heritage. From that, I'm jumping to selected profiles for Indian mathematical heritage. The Sulba Sutras, these form perhaps some of the earliest works next to the Rig Veda. The Rig Veda itself has got an enumeration of the numbers, it's got an enumeration of powers of numbers, and so on and so forth, basic operations of mathematics. But Sulba Sutra is one of the 6 disciplines of Vedanga, an appendix to Yajurveda. Major Sulba Sutra are credited to Apastamba, Bodhayana, Manava, and Katyayana. The mathematics over here has got right angle triangles, geometry, square roots, and numerals, concept of zero from Paninian rules. Shatapatha Brahmana shows all of this knowledge in the construction of altars and so on. And therefore, the Sulba Sutras are probably dated to earlier than 3000 BCE, because later on I'll show you how the Shatapatha Brahmana can be dated to that kind of a time interval. So this knowledge was transferred to West Asia around 1800 BC, following migrations after the drying up of Saraswati, as well as a 200-year monsoon hiatus that we had. We'll talk about this a little later. So here is the square root of 2 as discussed in Sulba Sutra. This is critically important for us because this forms a battleground with Professor Otto Neubauer, who says that Indians got their knowledge of mathematics from Babylon based upon certain ideas. We'll talk about that a little later. And it was based upon this tablet over here, which is in the Yale University collection, the Babylon cuneiform tablet over here. It seemed to show in base 60 system how to calculate the square root of 2. Sulba Sutra in this verse and this thing tells you exactly how this calculation should be done. It can be shown to be based on successive approximation by averaging, and it comes out to be the same square root of 2 as over here. Very, very interesting over here. So the question comes, who borrowed from whom? Or did they borrow at all? The base is obviously different, and Otto Neubauer seems to think that it was Babylonian, and we'll try to see why those ideas were. Surya Siddhanta is an amazing text. We don't know the provenance of that. We don't know when it was written, but there are statements that say that maybe Aryabhata's time. But Indian works always built upon a core body of work that is written by somebody else, layered upon by somebody else, layered upon by somebody else. So by the time it comes to Aryabhata, we know there are pretty ancient sections as well as recent sections. So this one has got chapters that talk about all these things here. I'm not going to read it, but very, very, very modern looking knowledge systems that you can see over here that talks about astronomy as well as mathematics. There are also time measurements in Surya Siddhanta, which if you take the second, if you map it to our well-known second as 1, you can see that they go to powers of the second up to a cycle of Brahma 10 to the power of 22, all the way to 10 to the power of -7. I still don't know why Indians would have had a need to measure time to 10 to the power of -7. It's enormously short interval. I don't even know what would have been there to measure such a passage of time, but it is there. A very, very brief history of numbers. Indians, we know, invented decimal numbers at least 2000 years ago. It was adopted by Arabs in 9th century. There was a book by Al-Khwarizmi on calculation of Hindu numbers, and a book by Al-Kindi on the use of Hindu numbers. And this diffused to Spain. In 976, there were 3 monks who wrote about this. And there's a Gerbert of Aurelic who wrote a book on multiplication and division. He became the Pope later, Pope Sylvester II, and used abacus based on Hindu numerals. And Fibonacci. In Fibonacci's book, in the margins, you can see there's a translation from Latin, rather Roman numerals to the Indian numerals. So that showed the mapping on how this was to be done. So he introduced the Hindu number 0 decimal place in 12th century, but even even then, Europe did not adopt it because the church believed that anything coming from the Muslims or others were works of Satan, and you should not take those works. So, although these ideas were introduced, they still use Roman numbers and so on until about the 15th century, 1522, when this German, he explained how to use positional arithmetic and decimal use for the calculators or the mechanics and others, how to use these numbers. Once he did that, then there was widespread replacement of Roman numerals in the 16th century. So this is the background of how they started using Indian numbers. Some recommended reading, there's The Origin of Mathematics by Seidenberg, and this book by Guy Verghese Joseph, as well as this book by Irfa. And obviously, I not put it here, but the works by C.K. Raju also all give a pretty good perspective on these things. Some of the greats on Indian astronomy, I don't have to read these, I've already done this in the past. So this is Brahmagupta, who did some enormously interesting works. He studied earlier works, proposed solutions of linear, quadratic, indeterminate equations, sum of squares and cubes, rules for zero operation, negative, positive numbers, theorems in geometry, trigonometry, interpolation, astronomy, quadratics, amazing amounts of works by this gentleman. Bhaskara 1, he wrote on the zero, positional arithmetic, and the approximation for the sine function addition. This approximation for sine function is very, very accurate. Even today, you could substitute it in your algebra equations if you didn't want to use this transcendental function. Bhaskara II, he wrote Siddhanta Shiromani. He also estimated the precision of equinox with an amazing number over here. We'll talk about this a little later. He had elements of differential calculus also. So amazing continuation of works by Indic people. Madhava of Sangama Grama in Thrissur. All of these expressions you see here were done by him. They were all infinite series, and he proposed how these infinite series can be expressed, and this is his work. So he's the founder of the Kerala School of Astronomy and Math, worked on infinite series, calculus, trigonometry, algebra, iterative solution of nonlinear equations, and Guy Verghese says his mathematics was transmitted to Europe a century before Newton by the church, and a lot of others following him. Yuktibhasha. This is one of the books that is in the news these days because this is written by somebody called Jeshtadeva, who was in the same school of Madhava. He wrote a Malayalam compendium of works of Madhava, Nilakanta Somayaji, Parameshwara, and Jeshtadeva, and Achyuta Pesharati, all these people. Seems to have foundation of calculus, predates Gregory and Newton, contains astronomy, mathematics of infinite series, integral solutions, series expansion, integration, differentiation. Amazingly modern pieces of work before the Europeans had a clue about doing these things, more than 100 to 200 years before that. The European line is that there's a person called Vesh who in 1832 published a paper on Yuktibhasha, long after Newton and so on. However, Indic authors like Guy Verghese and others state that these works were transmitted much earlier to the church via the church and trade also.